my channel. I'm Anna 10 Pencil. I struggled to do this question for day 9. I was doing, you can't see because my big old head's in the way, but essentially it was saying time limit exceeded, which means I was running something that was basically running the system out of memory, so I had to optimize it, and then I tried optimizing it, it didn't work. So that is, can I move my head? Yeah, okay. Yeah, so I started on the 8th, and then went through the 9th, obviously, and then kind of continued that until about a minute ago. I had been watching a couple YouTube videos. I can link those people in the description who helped me kind of get to this solution. This is not my own solution. I would not have thought about this. This is a solution I submitted. I used a couple bits from both videos so I could understand it better. So I wanted to go ahead and like explain this to you all, because I'm assuming there's going to be a lot of people in my same boat who had these issues. And then I'll explain these codes that I wrote. And even though they were accepted in the test cases, they exceeded the time limit it took to run the code to do everything else. So the day number 9 LeetCode question is 2,272, substring with the largest variance. The variance of a string is defined as the largest difference between the number of occurrences of any two characters present in the string. Note, the two characters may or may not be the same. Given a string S consisting of lowercase English letters only, return the largest variance possible among all substrings of S. A substring is a contiguous sequence of characters within a string. And then they give you these examples here, and then they give you the constraints. The first couple submissions I had, I did not look at the editorial. This one, it would have behooved me to look at the editorial because I did not know anything about Kadane's algorithm at all. I'm still like pretty new to that as a whole. It wasn't something that was like on the forefront of like everything I knew. So after I did that, I tried to recalibrate the solution, but I got 2 wrong answers. Then spent a little bit more time refining it, and then it was testing okay, but the time limit was exceeded again. So let's get into a breakdown of the lines of this code. So when we start here, I'm going to do this because this is going to be easier if I break it up in almost to like chunks. So the largest variance function takes string or S as a string as an input. It then initializes this empty dictionary for characters to store each character count in the string. And then it iterates each character over C. So if you guys are seeing this, my thing's probably not in memory, so whatever. It's great. Iterates each character over C in the string S and updates with the character count in the dictionary. This line right here basically just generates all the possible permutation length 2 from the keys of this dictionary using the permutation functions from inner tools. I didn't have to import inner tools. I saw a solution where someone did. So I don't know. I just ran it and tested it without it. But if your solution, you might have to go like import like up here. Import enter tools. Make it run. I didn't have to, so I just didn't. Okay, so I kind of lost my train of thought. Okay, so for count, this area right here, count 0 through return count, this basically just like initializes a variable count to keep track of that minimum variance found so far. So it iterates over each pair A and B in the permutations list. And then for each pair, we use the Kadane function arguments, A, B, S, and characters to calculate the variance, and it updates the count here with the maximum variance found. and then finally returns that maximum variance. So this is probably going to be better if I explain this as kind of a whole. So the Cadane function essentially calculates a given pair, like A and B, and returns that maximum variance. So it initializes variables like count and max local to keep track of those variances, and the maximum variance found so far. So we also initialize the Boolean variables is A and or is B to keep track of whether or not those characters were present. And then A and B would be represented in that substring. We also initialize the variables val A and val B to store the remaining counts of A and B in the characters dictionary. So then we have here, we break it down to a lot of if statements. And this is the part that really kind of got me a little bit, just because it was a little bit more back and forth than I thought it was going to be. So I'm going to try to explain this the best that I can and the best of my knowledge. So here we go. So essentially, if C is not equal to A and B, it continues to iterate. If max local is negative and val A and val B are both non-zero, it resets the max local resets the max local. And then is A and is B would go back to their initial states. If C is equal to A, it increments the max local, so it adds by 1, and then will decrement the value of A by 1 and sets is A to true. So what we saw up here, it makes it true. And then we did the same thing down here with B. So if both is A and is B are true, it updates the count with the maximum count of the maximum count and maximum of the max local. And then it finally returns that maximum variance count. So I hope that makes sense to people. Like I said, this part was a little bit hairy to me. I might not have explained it entirely correctly, but this solution works. My original solution, I will show you now, very, very, very different. I ended up by having to note it because I was I was working on this for way too long. I will never tell you how long I worked on this, and it was all recorded. So my initial thought was to initialize the largest variance to 0 and then iterate over all substring of S and extract, obviously I have a typo, extract the substring. And then I was trying to count each character in the substring and then calculate the variance of that current substring, and then update the largest variance if it was larger, and then return the largest variance. Because in my mind, that made sense, and it did make sense because, and I'll show you, if you run the solution, and it's going to drive me nuts, but I'm just going to, it was one of those days. If you run it, it works. So it works, but you can't submit it. That's the whole thing, is it would take way too long to actually go through all the 132 test cases, just because it just takes up too much memory. So when I spent time trying to optimize it, and then going to YouTube to help me figure out a solution, this was the one that stuck out to me the most because it makes sense, even though it feels like a little kind of beating around the bush a little bit, but learned a lot about this Cadane algorithm. And I am glad I got it done and bought the time traveler ticket so I can keep that streak though. Anyway, that's all I have for this video. I am going to put this in my GitHub repo and attach the tutorial to all of these videos so far. So feel free to fork and clone, make a better solution than my first one. Maybe you have a solution that would make this work. I couldn't figure out how to make it work. But hopefully you have some comments for me about what I could do differently next time. So I will see you guys in the next video. Thank you guys so much for watching, and I will finally drink my caffeine. Bye!